Welcome to TechNet 2021 and the Spectrum Bullpen Capabilities Brief. Automatic DSA Policy Tool, pronounced ADAPT, is a completed project under the direction of AFRL Rome, New York, which was delivered in October 2020 after a successful test event which took place in Stockbridge, New York, and remote planning of machine-readable DSA policies in Palm Bay, Florida. This demonstrated the ability to use spectrum management tools such as CJSPT and SPEED to feed data to ADAPT, which automated the creation of these policies and send them over the network to a remote location so that DSA radios could dynamically and automatically update their frequencies and mission policies.
Spectrum is the new warfighting domain, and the U.S. and its allies must keep pace with evolving near-peer adversarial threats. AFRL and Spectrum Bullpen have teamed up to tackle this challenge by creating a policy-based runtime DSA system that places spectrum automation and governance into a planning and operational platform for the U.S. warfighter.
Commander Alpha, priority. Respond immediately.
Checkpoint 1, say again. Checkpoint 1.
Status report.
Sir, the manual static coordination just can't keep pace with the required frequency changes. There is a lot of RF congestion from 5G cellular, an air combat training system, as well as multiple drones flying in the area.
Unacceptable, 6. What are our options?
Sir, the automated DSA planning tool, ADAPT, is here in the top. The DSA policy engine is already installed on our radios, as is the deployment tool to send policies to the radios. Let's give DSA a try.
Okay, 6, get it done.
Staff Sergeant, pull up ADAPT and prepare a coordinate and frequency policy for over-the-air distribution. This is all a policy engine, which we manage remotely.
Sir, the policies to coordinate DSA and frequencies have been prepared and sent to the deployment tool.
Great. I told our civilian counterpart we are turning on DSA coordinate policies. They are set to share with us.
Sir, DSA is operational.
Envoy Commander Alpha, I have a priority request for support. Respond immediately. I have an injury and require medical assistance.
Roger that. Assistance is en route.
Sir, DSA is working as planned. We have our comms and C2 fully functional.
Let's make DSA part of our future TTPs. Good job, Camo.
Artificial Intelligence Machine Learning Electromagnetic Spectrum System, affectionately called AIMLESS, represents an ongoing research and development project at Spectrum Bullpen. AIMLESS was an expansion of the ADAPT work completed to make a fully automated spectrum management platform. AIMLESS brings together artificial intelligence and machine learning with sensors and software to complete a package that automates the entire spectrum management process. AIMLESS's architecture includes capabilities to integrate live spectrum sensing with static data from a variety of sources such as current spectrum management tools, joint spectrum data repository, and our own AI/ML algorithms. This combination was used to help automate spectrum management while improving on the overall utilization of spectrum. Spectrum Bullpen has developed our own RF sensor to serve as a DF array at low cost but high accuracy. Two implementations of the DF array exist, a pseudo-Doppler approach using commercial off-the-shelf or COTS software-defined radio or SDR with a custom antenna switch, and a 4-channel interferometer using COTS receiver. These are both fully integrated to AIMLESS but can be used with other applications. Spectrum Bullpen's low-cost, low-power sensor array can perform single or multi-channel frequency scanning operations. Within AIMLESS, line of bearings, or lobs, are generated from each deployed sensor. From there, AIMLESS's C2 module aggregates these lob intersections, then we use a machine learning mean shift algorithm to discern the detected signals of interest and generate one or more potential geolocations. These geolocations can have an accuracy of up to 2.3 meters and can be visually depicted on the map as well as stored and or shared via the cloud. This scenario simulates 3 ship-mounted DF sensors around the northern part of Taiwan. Each sensor can operate independently, generating a line of bearing in the direction of the received signal. Aimless combines these lobs and processes them with our machine learning geolocation algorithm to locate the emitter. Further processing is available to the user to fingerprint the emitter for classification from a database of known emitters or cataloging the emitter for future identification and statistical analysis. Spectrum Bullpen has a research and development project as a part of Aimless focused on the use of AI and ML for spectrum management applications. These include propagation and emitter fingerprinting. Aimless's fingerprinting ML begins by first using our sensors to collect RF data to analyze and determine if it's a known or unknown emitter. This data is then shared with multiple datasets fused together to inform RF situational awareness. Once the ML identifies the characteristics of the emitter, a fingerprint is stored in the database. From this point on, that individual emitter can be positively identified the next time it is collected. Aimless uses a neural network to create path loss estimates for RF propagations. Using both historical and live sensor feed RF data, an on-the-fly improvement can be realized. This allows for propagation predictions to constantly improve as a mission progresses. Aimless allows for the fast creation of spectrum requirements through the use of automation, allowing the quick building of military units, their equipment, and RF network requiring spectrum assignments. As an example, building an Army brigade spectrum plan and other tools could take days or weeks to create, whereas Aimless's automation can reduce this time to hours. Aimless allows for fast, accurate visualization of the electromagnetic spectrum so the spectrum manager can determine potential interference based on the spectrum user's location, terrain, and altitude. This can allow for fine-tuning of systems to ensure the best use of assignments and increase spectrum sharing potential. Aimless has a CFAF template function which can be shared with subordinate users, allowing for standardization of CFAF content and enforcement of certain line item data. This increases the accuracy of the CFAFs and allows for more detail in other spectrum management tools. This is completely Pub7 and Spectrum 21 compatible. Once the spectrum requirement data and location configurations of the system is complete, Aimless has automation to build the CFAF of the entire operation in either Pub7 or Pub8 format. Aimless has a CFAF editor which utilizes automation to identify Pub7 or Pub8 errors and provides automation to eliminate them quickly. The errors are identified by stop signs. Also, Spectrum 21 validation issues are identified by exclamation points which can be corrected or overridden. Once the CFAF editor work is completed, a completely Spectrum 21 importable CFAF is created automatically, including far more detail of the assignment than a typical manually created CFAF will have. These can be imported directly to Spectrum 21 for assignment nominations. Aimless tracks the assignment status of each RF network in an easy-to-read format. Once assignments have been completed in Spectrum 21, the CFAF assignments are imported into Aimless Spectrum Resource Manager and Assignment tool. This will ensure assignments are made in the best use case based on the details of the plan created and ensuring maximum non-interfering sharing. Once assignments are applied to the nets in Aimless and the mission progresses, there will be a need to make changes to the spectrum assignments. Aimless has the capability to model thousands of emitters simultaneously and provide the details required to mitigate potential interference to include electronic warfare. As seen in this scenario, we have a sortie of 3 UASs and a ground patrol that are moving. The coverage plot of the UAS provides an understanding of their propagation in support of the patrol. This mission, with systems on the move, may not have been planned prior to the original assignment of spectrum. Now we must determine if any changes are required based on this new mission and the parameters. The aircraft that took off is modeled as it climbs in altitude and shows the interference is predicted with the ground patrol as the aircraft gains in altitude. Other moving systems are not impacted, as you can see from the UAS flying during the mission. Using Aimless's Spectrum Resource Manager, the required frequency changes to mitigate this interference is automated and simple to apply. Spectrum Bullpen prides itself on continually challenging the norm with enhanced electromagnetic ideas. From new ultra-high bandwidth antennas to modeling enclosures, we use our CAD, CAM, and 3D printing hardware and software to push the envelope in novel ideas. In December of 2020, Spectrum Bullpen delivered to the Navy, as a part of a SBIR, an ultra-high bandwidth antenna to be used on an unmanned underwater vehicle. This included a novel approach at using a homegrown, solid-state tuner which also controlled the deployment of the antenna. Spectrum Bullpen thanks you for your time listening to our capabilities brief. We are located in sunny Palm Bay, Florida with over 1,500 square feet of office and lab space and 11 employees. Please take a business card and brochure and enjoy a great conference event.